Good morning, students. So the second exercise that we have studied, that is 3-point problem in hydrographic survey. 3-point problem in hydrographic survey. That is 3 are given. 3 points are given, and from those 3 points, you have to find out the position of the boat by observing the horizontal angles from the boat. So in the field, how to take the observations that you have studied, that is, there are three objects on the shore. Those are taken, that is A, B and C. So that I am showing here as A, B and C. Actually this I have taken with some units. I have considered it as AB as, or the 5 unit. AB is 5 unit, BC is 5 unit, and CA is 5.5. So these distance measurements that you have to take, these points are on the shore, that is A, B and C, points on the shore, and alpha and beta angle, that is alpha and beta angle, that is 10 degrees. Alpha angle is 10 degrees and beta angle 5 degrees, that is AOB, and BOC 5 degrees angle. These are observed from the boat. These are observed from the boat, and from this angle measurements and these three distance measurements, that is AB, BC and CA, and two angle measurements, that is alpha and beta, you have to locate the position of the boat. So that is 3-point problem. So first, with reference to these distances, that is AB is 5 centimeter, AB is 5 centimeter, that is taken over here, and with BC 5 centimeter arc is made over here, and CA 5.5 the arc is made, and this point C is finalized. Point C is finalized. So this triangle you get, just I will close this triangle, that is ABC, the three ranging rods that we had fixed in the field. All the three sides you have to measure, and you have to plot it graphically like this, by measuring all the three distances. By measuring all the three distances, you have to plot the three positions of the ranging rods on the paper, and whatever alpha is the angle that I have shown you here, that is alpha angle AOB, that is measured as 10 degrees, and B, this is between A and B. AOB, this 10 degrees alpha angle that is observed between A and B. O is somewhere here, it may be somewhere here, and this AOB is measured as 10 degrees. So that 10 degrees, you have to make 10 degrees at C point. Angle is measured between A and B is 10 degrees with reference to O. That angle you have to make at C, at the third point. So I have marked here a dot over here. So just I will draw the line like this at 10 degrees. 10 degrees. Okay. So this is 10 degrees. Just I will write it. This 10 degrees is the angle observed between A and B, that you have to make it at C. Now the next angle I have told you, that is alpha and beta angle. That is angle beta 5 degrees. Angle beta 5 degrees, that is measured between B and C. BOC, it is measured between B and C. So you have to make this 5-degree angle at A. You have to make 5-degree angle at A like this. Using this protractor, you can make this 5 degrees somewhere here and draw the line. Okay. And the intersection point, you call it as, say, P. That is APC. This angle is taken 5 degrees. This angle is taken as 5 degrees. Now you get this AP and CP. You are getting this AP distance and this CP distance. You have to bisect this AP. Means you have to take the midpoint. You have to draw a perpendicular bisector. You have to draw a perpendicular bisector to this AP. So I'll take the midpoint of this. This is 3.8, around 3.8. So 1.9 I will take. And this perpendicular bisector to AP as well as perpendicular bisector to CP I have to draw. So this distance also I will measure. This is 1.9, around 1.9. So 0.9 or 1, somewhere here I will mark the midpoint. And now you take the perpendicular to at these points. Perpendicular at these points. Perpendicular to these. By drawing the arc also you can do it, or by the set square also you can take the perpendicular bisector. So this is perpendicular bisector of this, and here also I will draw the perpendicular bisector to CP. Okay. So this perpendicular bisector over here, and this second one. Somewhere here it is intersecting. Now you have to draw a circle with this center. So this is center of the circle. So this is intersection of the perpendicular bisector, that whatever you are getting, that is center of the circle. Center of circle. So radius, and radius equals to this circle will pass through this A, P and C. This is the center, this will be the center, and radius will be equals to this. Radius will be equals to, if the center, if I call it as say E point, then this AE, it is around 9 point, how much, 9.7, 9.6 or 9.6, it is coming 9.6. All these 3 points, this is perpendicular bisector of this chord and this chord. So this circle will pass through this A, P and C. It will pass through A, P and C, and you will get a big circle. You will get a big circle of radius. How much this is? 9.6, around 9.6. So just I will take some points at 9.6 at some distances. Nine 9.6. You can draw the circle with the rounder. And you can complete the circle. Nine 9.6, that radius you are getting. So this 9.6 circle you have to complete. So I am using another page here. This is 9.6. It is coming somewhere here. So the circle is something like this. It's a big circle. Okay, 9.6 somewhere here. It is coming here. So just I'm drawing this circle. Okay. So this way, if actually this part is required for you, so the circle is coming like this. And if you see, this is the upper part, and this is a big circle that I will just make it slightly darker so that you can get it properly. Okay. Now I think you can see this three triangles, perpendicular bisector that I have told, and this circle is slightly bigger. It is like this way. It is a circle. Actually, this much part is sufficient. uh, it is not necessary to complete the circle. Actually, what next you have to do, that is this much part is sufficient. The next part, that is this p point that already here, and this b point, the middle ranging rod and this intersection point, you have to join these 2 points. You have to join these 2 points and you have to extend it. Just this line, I will mark my dash line like this, and you have to extend it beyond. It cuts the circle at this point. Just I have extended it, and it cuts this circle at the point, this point. This is O point. This is the point which is required, from where you have taken 10-degree angle and 5-degree angle. 10-degree angle and 5-degree angle, that is taken from this is the position that is to be determined. That is 3-point problem. 3-point problem. This is the position of boat, or this is the position of nautical sextant. Nautical sextant, from where the two angles alpha and beta observed. from where alpha and beta observed. So this way you have to complete this exercise. Just I will draw this line with A and B. This another point also, C point also I will join over here. Okay. So this angle will be 10 degrees and the other this side angle will be 5 degrees. 10 degrees. This angle, that is AOB. Just I will show you the remaining part that I have joined it to A and B. It's slightly bigger one, so you can see it. So this is the triangle ABC. ABC points, A point, B point, and C point. AB is 5, BC is 5, and CA is 5.5. Then alpha beta angles, that is alpha and beta angles, those are given as 10 degrees and 5 degrees, isn't it? Those are given. So whatever between A and B, it is 10 degrees. This 10 degrees you have to make at C. And from between B and C, it is 5 degrees that you have to make it at A, and you have to draw the lines. So those are AP and CP lines intersect at P point. Intersect at P point. Then thereafter, you have to draw the perpendicular bisectors for this AP and CP. That is, this is the perpendicular bisector that is drawn to AP. And for CP also you have to draw the perpendicular bisector that is coming like this, and it is intersecting at this point. This will be the center of circle. This will be the center of circle. This I have named as E, some different point as E. And with this center and this EA as radius, this EA as radius, actually this circle will pass through A, P and C. A, P and C. So this is a big circle. So that circle is drawn, that just you can see the circle. So it is drawn like this. Actually the full circle is not required also, this much was sufficient, so I am not completed, but you complete the circle. And thereafter you have to join this P point and the middle point B, this intersection point P and B. This you have to join and you have to extend it till it cuts the circle, till it cuts the circle. This is the required point of nautical sextant. So the purpose of this is that with reference, these positions of these 3 points are known. A, B, C, the position of these 3 points are known, and you have to find out with reference to these 3 points, you have to fix the position of O. That is from where these two angles are observed. These angles you are observing with the nautical sextant in the boat, inside water. You're going inside water with boat and the nautical sextant, and wherever your boat is, that is determined by taking these two angles to the objects on the shore. These are the objects on the shore, and this is the point inside water. So just I can in between, just I can draw a shoreline, and this is inside water, this is shoreline. You can see this is, just I'll write shoreline. Shoreline. This way you have to complete this exercise. This is graphical method of fixing the position of solution of 3-point problem. Graphical method. Thank you very much.